All right, let's continue with arithmetic sequences, or arithmetic. Now this D term is called the common difference. I'll explain what the common difference is in a second. So let's look at this example 1 before we get to what explicit formula is. It's obvious that the pattern is changing. Now we need to determine if it's a constant addition or subtraction and what that value is. That change is called the common difference. Well, if we notice here, the common difference looks to be subtracting 4. Pretty consistent on both of them. So in the first position, the answer is 9. In the second position, the answer is 5. In the third position, the answer is 1. And they have a common difference of 4. I mean, negative 4, excuse me. So the explicit formula. This formula allows us to determine maybe the 50th term or the 100th term. We don't want to continue to subtract 4 each time. This formula helps us get there. Well, if you notice, it says a sub n. A sub n stays as like a variable, almost as if it's a y. A sub 1, well, I happen to know what a sub 1 is. It's the answer in the first position. Here it's 9. Plus, n minus 1, it counts like a variable. The n is almost like the x. And the d, the common difference, well, I found that. It's minus 4. Here is the formula. It's called the explicit formula. Well, we also know how to do the function rule here. Well, the function rule is, in this case, we'll use a sub n is equal to the change of the y divided by the change in the x. That's negative 4 times the n value. Well, if I multiply, let's say 2 by negative 4, I get negative 8. I need it to equal 5. Negative 8 all the way up to 5 is an addition of 13. This is a linear equation. This is the explicit formula. If you actually worked out the math and distributed it and solved it, it would actually come out to the same formula as our linear equation. So again, if I said what's the 50th term, you could plug in 50 here, do the math, or you could plug in 50 here and do the math. Well, what happens when I give you the formula? If I give you the explicit formula, well, we can extract some information here. For example, I can make a table. I happen to know what the first position is. The first number is negative 3. This common difference tells me what it's changing by. Looks like it's increasing by 2 each time. So if I were to continue this pattern, I'd come out with a new table. Now one more thing, there's another version of this arithmetic, and it's called the recursive formula. And all the recursive formula is follow the pattern. Well, if you notice, a sub n equals a minus 1. Do you remember what that meant? Well, a sub n is like the now number I'm looking for. I'm looking for what number I have right now. This was before. And then what I'm going to do is add my common difference, which we have to figure out. So let's just use this example 1 again. If I am looking for the a sub 3 value, well, in order to find the a sub 3 value, I need the one before. Well, 3 minus 1 is a sub 2. Common difference in this set, common difference in this set is negative 4. So, if I take the a sub 2 value and add negative 4, I'll get my a sub 3 value, which is 1. Let's do it again. Let's say I want my a sub 4 value. Slide that down. I don't know that from my table, but I could figure out the pattern. In order to find a sub 4, I need the previous answer, which was my a sub 3, and then I add my common difference, which is negative 4. Well, a sub 3, I just got it. So basically what this is continuing a pattern all the way through. And that's the basics of the recursive formula for arithmetic sequences and the explicit formula for arithmetic sequences.